Here we see the initial washing phase, where the raw tamarind pods are vigorously agitated in stainless steel tanks to remove debris. The high-pressure nozzles ensure that every pod is thoroughly cleaned before moving on to the sorting stage.
Ready? Lift!
The pods are rapidly vibrated on stainless steel trays, allowing the smaller debris and twigs to be sifted out before the next stage of processing.
Here we see the tamarind pods as pods weighed. Startling each exact reason exactly it's a space to the ground.
Here we see the initial washing phase, where the raw tamarind pods are vigorously agitated in stainless steel tanks to remove debris. The high-pressure nozzles ensure that every pod is thoroughly cleaned before moving on to the sorting stage.
Here at the washing station, the freshly harvested tamarind pods are thoroughly cleaned by these rotating brushes before moving on to the drying stage.
The washing station utilizes a high-pressure spray system to clean the pods as they move along the slanted conveyor belt.
The conveyor belt moves the freshly harvested tamarind through a series of high-pressure water sprays, removing any residual dirt or debris.
The automated sorting system utilizes advanced optical sensors and vibrant blue LED lights to
Here in the sorting area, optical scanners rapidly assess tamarind tagging. Lasers.
Every pod is manually inspected by our trained staff to meet the stringent quality control standards required for export. The tamarind pods travel up this steep incline to reach the processing area on the factory's second level.
The pods fall from the conveyor belt into these large, rotating spiked metal rollers, which are specifically designed to crack the tough outer shells efficiently.
Here at the deshelling station, the pods are fed into these spiked rollers, which efficiently crack the brittle shell and expose the pulp.
The stainless steel mixer ensures a consistent flow of the thick tamarind pulp, moving efficiently along the conveyor system in this sterile environment.
Keep an eye on the moisture levels as it approaches the dryer.
Roger that. The current batch seems consistent.
Inside the BG3 mixing tank, these paddles ensure the dark brown tamarind paste is blended to a perfectly smooth, uniform consistency. This is the extrusion station, where the thick tamarind paste is forced through a die, creating the fine, fibrous strands you see here. The mechanical blade ensures a precise, even layer of the tamarind fibers, crucial for the drying process. As the heavy piston makes contact, the dry pods crack, releasing the thick, sticky pulp critical for the next stage of processing. The heavy-duty hydraulic piston applies intense pressure, crushing the tamarind pods and forcing the sticky pulp through the perforated grate below. In this phase, the BG6 system exerts intense pressure, forcing the dark, sticky pulp through the perforated grate for extraction.
The sorting area processes thousands of pounds of tamarind every hour, destined for markets worldwide.
Here in the mixing area, a continuous stream of fresh tamarind pods is introduced into the swirling base liquid, beginning the extraction process.
The press descends deep into the vat, confirmed by the green indicator. As it rises, here in mixing area BG-8, the tamarind pulp is processed before fermentation.
The BG9 infrastructure is designed for maximum throughput, capable of processing millions of liters an hour through these polished conduits.
Designed to handle extreme conditions, the valve assembly automatically vents the system, preventing dangerous pressure buildup within the stainless steel pipelines.
The green trend line indicates a healthy increase in flow volume across the system. The automated monitoring is working within optimal parameters.
The journey of the cocoa bean continues as they are steadily fed into the large hoppers for the next stage of processing.
Here in the mixing station, the cocoa liquor is kept at a precise temperature to ensure that smooth, consistent texture.
As the white mist hits the hot cocoa, the temperature gauge holds steady at 85, a critical step in the process.
This vat, designated BG11, utilizes a high-powered motor to create the perfect vortex for optimal mixing.
This powerful vortex ensures every particle of cocoa is evenly coated, resulting in the rich, glossy chocolate you see here.
The BG11 mixing station maintains a precise 85.0 degrees Celsius, showcasing the critical heat control of the process. This thick, dark brown cocoa paste flows steadily, ensuring a consistent supply for the refining process.
This thick, dark brown paste is churned rhythmically, refining the texture until it reaches the perfect consistency.
The smooth, viscous liquid is maintained at a precise temperature as it fills the stainless steel container, ensuring perfect consistency.
Here at the discharge station, designated BG14, the freshly ground cocoa nibs are collected before moving to the conching stage.
Here at the BG15 dumping station, the mechanical hopper releases its load, a dense mixture essential for processing.
At the heart of the facility, the liquid extraction station meticulously separates the rich, amber cocoa butter.
As we can see through the sight glass, the yellowish liquid is flowing steadily, monitored closely by the pressure gauge.
At the heart of the BG17 station, the pumps work tirelessly. The gauge reads 10.0.
As we can observe on the sensor, the temperature at this point in the system is decreasing, moving 56.2 degrees Celsius.
Here at BG17, we see the oxidizing agent being introduced into the mainstream. Note the turbulent flow dynamics at the junction. The BG18 mixer ensures a consistent viscosity, rotating at 10 RPM to create the perfect vortex for optimal blending. As you can see on the PLC panel, the current batch temperature is stable, well within the safety parameters highlighted in green.
Currently at 55.2 and 4.8. Opening the bypass valve slightly to correct the fluctuation.
pH 5.8, bricks 1.85. Make sure that's logged. As you can see, the system is maintaining a steady flow rate of 150 gallons per minute through the main pipeline.
Welcome to the heart of our new processing facility. These tanks are capable of handling millions of liters.
Starting the CIP sequence now. System parameters are nominal.
As you can see on the main display, BG precisely operating.
Make sure that bin is secured before it fills completely. Already on it, boss.
Here we see the BG24 separator at work. The clear amber liquid is fully separated from the dense brown solids, ready for the next stage.
Pressure levels remain unstable. The leak rate is increasing steadily. We need to initiate shutdown procedures immediately.
As you can see, the BG25 nozzle provides a steady and precise flow rate, ensuring optimal extraction.
As you can see, the BG26 dispensing system provides a consistent flow of our premium aged amber liquid, ensuring perfect aeration.
Warning, pressure 40,000 and climbing, 90,000 psi, approaching maximum threshold. Overflow detected.
Okay, pressing the button now. Got it. 3, roll on 3, 1, 2, 3.
Here we have the output from the BG29 stage, transferring the concentrated solution to the holding vat.
As you can see through the BG31 sight glass, the flow rate has stabilized, and the filter is operating within optimal parameters.
The amber liquid enters the filtration chamber where the specialized mesh traps the suspended black particulates. This ensures a clear, high-purity output.
Check the flow rate on vat 3. Looks steady at 200 liters per minute, almost full.
The amber liquid is currently flowing at standard pressure. Monitor the levels in tank 3 and ensure the vortex flow remains stable during the transfer process.
Okay, opening the valve now. We need exactly 50 milliliters of the amber solution. Closing the valve. Sample secured.
Sample 3B, lot 4. Dispensing 1 drop into the medium.
As you can see, the system pressure remains optimal within the green operating range, ensuring consistent product flow.
Keep the flow steady. We need this vat filled before the next shift arrives.
This facility represents the pinnacle of modern engineering, utilizing a complex network of pipes to ensure maximum efficiency and purity.
The temperature in the vat is currently exceeding 250 degrees Celsius, ensuring rapid evaporation and concentration of the amber solution.
The flow rate is steady and the bricks reading is exactly where we need it at 68.5.
The current bricks reading is steady at 68.4, occasionally hitting 68.5. The flow rate is consistent.
The HMI continuously monitors the process. Note the flow rate adjustment to 525 liters per minute and the All systems are currently operating within optimal parameters. The pressure differential remains stable. Here we see the thick, chocolate-like dough being extruded from the stainless steel nozzle at a steady, controlled rate.
Here in the mixing facility, we ensure every drop of our rich, dark chocolate is slowly stirred to achieve the perfect consistency.
The viscosity on this batch looks perfect. It's flowing smoothly into the holding bucket.
I have the chocolate sample ready for the refractometer.
Great, set it down here and we can begin the analysis.
Data accepted. The process ensures a consistent viscosity, resulting in the perfect temper every time.
Temperature is climbing rapidly on the HTST panel.
Reaching 105 now. System stabilized.
Temperature holding steady at 135 degrees Celsius. Processing is optimal.
Only the finest quality cocoa goes into our signature blend, resulting in this rich, velvety smooth liquid.
All systems are currently operating within nominal parameters. Flow rate adjusted as requested.
And here we see the actuator engaging, releasing pressure through the vent before quickly resetting.
The dark chocolate run is proceeding on schedule. Vats are at 90% capacity. Ensure optimal temperature levels are maintained.
I'm carefully drawing the required amount of the dark chocolate sample here, making sure to avoid air bubbles before depositing it onto the plate.
Did you log the aerobic plate count yet? I need the results for the yeast and mold by 3.
The quality control check for batch 7 gamma is complete. The results indicate a clear pass.
Checking the HTST parameters now. Temperature is 105.1, hold time 20 seconds. Looks good.
All right, logging into the traceability system now. Looks good. This heavy mist and pressurized spray guarantees a thorough cleaning of every jar before it moves to the next stage.
The temperature in the sterilization tunnel is holding steady at 90 degrees. Keep the conveyor moving at the current speed.
Sterilization cycle active. Jars approaching cooling zone.
This is the BG66 rotary filling machine. The pistons move vertically, positioning the glass jars precisely under the nozzles for the filling cycle.
Here we see the jars being filled at 90 degrees Celsius before moving to the automated capping station. The automated system ensures a precise seal on every jar, maintaining optimal freshness and flavor. In this prescription, the BG67 model ensures healing thousands of RC. The BG68 quality control system ensures that every lid is perfectly sealed before leaving the factory.
Automated sorting solutions, such as this specialized vacuum gripper, ensure efficiency and minimize breakage.
The BG70 tunnel ensures a sterile environment, utilizing high-pressure nozzles for a thorough pre-rinse cycle.
Here in the BG71 washing tunnel, the jars are subjected to intense, high-pressure water sprays from force.
The hot filling process requires rapid cooling, which is where the BG72 chamber comes in. As the jars move through
the jars undergo a rigorous high-pressure wash, ensuring sterilization before the final sealing process.
Here at the facility, every jar is precisely weighed to ensure quality. The target weight, as you can see, is exactly 500 grams.
The BG75 conveyor system ensures precision. Here we see the pneumatic arm rejecting a faulty.
This machine, the BG76, is crucial for quality control, automatically detecting
rerouting the data visualization to the main holo display.
Confirmed. The error rate is stable.
We check every single jar for imperfections before it moves to the filling line.
We rotate every jar, checking the seal and the consistency of the brine. It's critical before it proceeds down the line.
Seal is secure, and the product consistency is within specification. We can release this lot.
Operating 24 hours a day, this automated production line fills over 10,000 jars an hour.
With mechanical precision, the BG80 applies the premium tamarind paste labels, ensuring consistency across the entire product line.
This high-speed laser etching system can mark up to 200 units per minute, ensuring precise tracking of production and expiration data on every gold lid.
Utilizing high-speed cameras, the BG81 ensures precision. Each flash confirms the jar meets our strict quality standards.
The BG80 mechanical rejector arm is crucial for quality control, swiftly removing any jars that fail. Each jar is meticulously catalogued here in the quality control archive to ensure consistency across every batch.
The quality control archive holds samples from every batch, stored under optimal conditions for future reference.
Every day, millions of these glass jars begin their journey through our state-of-the-art facility.
The CAR 8 robotic arm precisely lifts 4 jars simultaneously, demonstrating the efficiency of modern automated packaging systems. The BG84 system ensures precise folding at speeds up to 20 boxes per minute, minimizing human error. The BG84 packing station automates the sealing process with precision, ensuring a perfect seal every time. The BG84 applicator precisely places the shipping label, demonstrating the efficiency of the automated packing system. Here we see the CR9 in action. Its specialized gripper precisely secures the box before rapidly transferring it to the palletizing area. The robotic arm, utilizing its pneumatic gripper, places the final box onto the pallet, completing the shipment with automated precision. The BG86 automated stretch wrapping system optimizes the workflow, securing the load precisely as it moves down the line.
Make sure the tension is set correctly on the film, otherwise the boxes might shift during transit.
The labeling arm extends, utilizing vacuum suction to secure the large white barcode onto the pallet's plastic wrap. The AGV system uses laser guidance to scan the pallet, ensuring precise alignment before the forks engage and lift the load for transport.
Approaching designated bay. Pallet deposit sequence initiated. Slot confirmed.
Returning to charge station.
The temperature is 18 degrees Celsius and the humidity is 55%.
The digital twin is showing congestion in aisle 5.
I see it. Rerouting the next 10 units now.